Hello and welcome to Foresight Reality. Once again, we will be playing with fire. However, this time, we will be colouring the flame itself. Alas, we will not be using a lighter as such though. We're going to be using the far easier to clean spirit burner with methylated spirits as a fuel. As you can see, it's a bit worse for wear, hence why I don't want to use my lighter for this. To do this, we're going to be doing flame tests, which is where you test to find out what metal ions you have in a compound by burning them. Each one burns a different colour. I've got my chemicals, I have my spirit burner. Let's do some science. First into the flame are the iron filings, with a glorious golden energetic spark. Next we have the Magnesium Ribbon. This burns vigorously and can be painful to look at with a naked eye. In fact, the flash causes me to drop the ribbon the first time. And now I repeat the experiment with the camera set to a much lower light sensitivity. Cobalt chloride is not a common flame test, and it takes a while to ignite, but when it does you can see it reacts similarly to the iron filings. Potassium iodide has a much more subtle effect. I really wish I had a clearer flame to repeat this with, but if you look carefully you can notice the lilac licks the flame takes when it starts to ignite. The lilac flames continue sporadically for quite a while. My copper sheet just would not burn, but thankfully I had a stash of copper sulfate which put on a spectacular show of green flames. Taking a pinch of copper sulfate powder and throwing it into the flame worked even better. So why do we get these colourful flames? It's all to do with the electrons. They're the things that orbit around the atom, right? Well, not exactly. This image is based off the Niels Bohr model of the atom, which described the electrons as being in orbits. Thanks to quantum mechanics, we now know that's not the case, but that's a whole other video. However, it is still used to introduce concepts such as energy levels. The circles represent each energy level, and every electron on the same energy level has approximately the same energy. This does however get less and less accurate the more electrons you add. Electrons are able to go up an energy level if you provide the right amount of energy in, say, the form of heat. However, this new position is unstable, and the electron will release energy in the form of a photon in order to move back down to its original level. The configuration of electrons in metals means that they generally radiate visible light when we heat them up like this. However, some non-metals also behave in a similar way, such as carbon compounds heating up and glowing orange, as seen in the common flame.